Thank you. I'm really glad to be here and to be presenting this new system. It's a new approach to measure grouting columns diameter. But before we go into this, I would like to give you a quick overview of grouting columns diameter control methods. So we can divide them into large families: direct control methods and indirect control methods. Direct control methods are excavation of the grouting column, coring, mechanical calipers, and painted rods. Indirect control methods, the list is not complete. Anyway, we can have temperature, geophones, hydrophones, sonic waves, electrical resistivity. Now, excavation is pretty self-explanatory. Basically, you dig up the column. It is 100% reliable. It is what you get, and but it's very expensive and possible only with shallow columns and only with hard columns. The next method, direct method, is a mechanic caliper. So the mechanic caliper, as you can see from the picture, you lower the caliper inside the grouting column, and then from the surface you operate the opening of the caliper, and therefore you have the diameter. So problems with this approach might be proved difficult to re-enter the hole with an hydraulic device like the one you see in the picture. And how to know the position of the caliper inside the hole, and how to know when the tips of the caliper touch the surrounding soil. The other system are painted rods. Painted rods, for those that are not familiar with the system, well, basically it's a rod that is painted. You insert the rod into the ground in the vicinity of the nozzle. If the nozzle hit the jet coming out of the nozzle hit the painted rod, it will discolor the rod. Okay, and because the rod is discolored, then you have an indication of the radius of the column. What are the problems with this method? Well, it's not easy preserving the paint. There are systems. You can case the hole with PVC, or you can put plastic covers on the rod. But most importantly, how to know the position of the rods on the ground, the soil. If you have a deviation, the measure will be impaired. Another system, more evolved, but similar to painted rods, is hydrophones. The nice thing with hydrophones is that you have the measure during the making of the column. But here again, you need to drill a hole, fill it with water, then put the hydrophones. As soon as the jet hit the hole with water, you can detect noise. Therefore, you have an indication of the radius you are getting. Okay. The other system is coring. Here, well, pictures are self-explanatory, really. Only possible when the column is hard, dries out, and again, how to know the exact position of the core sample. This is the main thing. You need to know where are you taking the core sample. Temperature, well, again, you need to know the position of the thermal sensor, and it takes quite some time to have an idea, to collect the data, 30 hours. And temperature is an indirect method, so it needs interpretation. The other one is electrical resistivity. SealJet is the registered mark for this. And here, there are multiple operations you need to do. First of all, you need to drill a hole and run the electroresistivity test on the virgin soil. And so you have a first batch of data. And after that, you need to re-enter the fresh column, collect all the resistivity data. And if it's not possible to re-enter the fresh column, then you need to wait so that the column is hard and get again in the column and run the test. In both the holes, you need to know their verticality, their position. And of course, you need to interpret the data. Okay? It's not straightforward. So it takes some time to feed the softwares and to have a result. So before we leave these methods, let's recap what are the problems with them or the requirements. First of all, you need to determine the underground position of the sensor calipers. Time of survey, very good when it's during jetting. Acceptable with fresh column. When the column is hard, 3 days have passed, maybe it's too late. Then there is the thing of interpretation of data. It takes time. And what is common to all these methods, the very common problem is long operations, preparations for taking the measure. Now, before we go into detail of the check Grout system, let's have an overall view of it. On the red box on your left, you see all the parts of the system. So we have a preventer unit that goes on top, a deviation unit that goes at the bottom. We have blue flex pipes and a special inclinometric chain we designed in joint venture with Measurement. So on your right, you can see actually a measure that is being taken. So it's pretty visual. You can see it. But let's see how we get to that. So first of all, step one, you make a jet grouting column. Step two, you exit the hole and remove the jet grouting monitor. After that, you add the deviation unit. The deviation unit, basically, it is a device that allows the flex pipe we saw before to have an angle when it exits from the deviation unit. And it's about 20 degrees. And the thing at the bottom of that hole, the red thing, is a pneumatic piston. And if you open the piston, you will reach 20 degrees more. So step 4 is re-entering the hole. Step 5, you open the drilling string and add the preventer unit. And the preventer unit is basically what allows you to pump air inside the drilling string to open the piston that is at the bottom. And also, he has a 1-inch inlet to pump water in case you get stuck when you retrieve the flex pipe. Step 6, you insert the flex pipes with the inclinometric chain. These flex pipes are very light, very handleable pipes made of a special polymer that allows you to reach a steep bending radius without exceeding the plastic deformation point of the pipe. Step 7, you deviate the flex pipe and start to measure the column radius. So what you see here, basically, it is the piston, the air piston that it's opening and is deviating the flex pipe. Step 8, you reach the virgin soil, you reach the inner wall of the column and check radius in real time. So what you see on your right is basically what you will see on your laptop that is connected to the chain that is inside the flex pipe. And as you can see, the tube, the white tube, is basically the shape, the actual shape that the flex pipe is having when it's traveling through the jet grouting column. And these are reports you can easily do with the data you record during the survey. And these are some pictures from the field test we ran in March 22 in Italy, Colleferro. And now let's quickly see what are the points in favor of the check grout system. So first of all, the position of the flex pipe is always known. No need of that interpretation. Basically, it is possible to use this system without continuous technical assistance. You just need a training day with our technician in the field, and then you will be autonomous. Measure is available when the column is still fresh and in real time. Operations to get measured are quick, and the system is quite cheap. Now let's see some possible objections to this method of measuring the radius. First question is, how do you know you have reached the virgin soil? Second question is, when touching the soil, can the flexible pipe move the drilling string and change the starting point of the measure? And can you use the check grout when you have inclusions such as boulders, big cobbles, or gravel? So about the first question, how do you know you have reached the virgin soil? Well, in my experience, I did myself some measurements. You immediately know because you cannot go farther, okay? But the check grout system, it also gives you another result because it uses an inclinometric chain with temperature sensors. So when you are close to the untreated soil, the temperature will tend to be lower. And the lowest point will be exactly the last section, that is the one that is touching the soil. And the other question is, when touching the soil, can the flexible pipe move the drilling string? Here the idea is that you should imagine, that this drill string is like 20 meters long. And you are taking the measure at the very end of it. So you might have this column sort of moving away from the wall of the jagged column because the flex pipe is pushing. No, I mean in theory, yes, this could happen. Never happened to us, but it really doesn't matter because if this happens, you know this happening because you can actually see it, and there are ways you can calculate the radius. So if you notice this phenomenon, you do it on the opposite direction, and then you can have with some calculation the real radius. And the last question, the last sort of objection is, can you use the check grout system when you have inclusions such as big cobbles, boulders, or gravel? Well, in this case, we say that if you have individual, isolated inclusions, then you can try to change the path of the flex pipe. But if you have gravel, it might be difficult to pierce gravel. And so in this particular case, we discourage the use of this the system. Thanks for your attention, and if you have any questions, I'll be more than happy to answer, if I can.
Thank you, Valerio. Any questions?
Thank you very much. Future customer of your system, I think, here, so appreciate your time. But in your experience, how long do you think you have? I haven't used Grout slurry for this. For how long do you think you have to do these tests before it becomes too stiff? Sort of an hour?
No,
or longer?
no. Well, the test we did was in clay, so it was very easy soil, okay? And it was really quick to come up. So it was like 5 minutes to be out of the column. Then they had some problems in removing the monitor. So, and the deviation unit is 50 kilos, so it's quite heavy. Takes some time. And that was the longest part. So the measurement itself was really, really quick. All in all, we measured 30 minutes, 35 minutes, something like that. But obviously, let's say that you have a very difficult soil and you exit the hole and then the soil collapses again. Then you need to re-drill, not re-enter. And that might take a little bit longer. And obviously, if you are, having your column at 80 meters depth, then it will take longer.
Oh, thank you. Any other questions?
Hey, Valerio, do you currently have the system here in the U.S.?
No.
How long to get it here?
To get it here, we have a unit that is ready, a stock. So it would be like 10 days, something like that.
Just a quick, up to which the diameter can be utilized?
Well, we don't have particular restrictions. The unit we have on stock has a 2.5 meters long chain, which means that you can measure a radius of about 1.8 meters. A radius. This means, a larger diameter, like 3 meters and 60. But if you want to go, if you have a special project, and you want to measure a 4 meters column, you just need to tell us, and we will give you a longer chain so that you will be able to reach that radius. So, but if again you need to measure 4 meters, you want this chain 2.5 meters is too short. So you need to buy a longer one. It's possible. No problem.
The question for operator, if I understood you correctly, when you test it, do you rotate it around and check multiple points around the shaft?
This is up to you. You might be happy with just one single point, or you might want to be able to measure on multiple points. You can also move up the drill string, okay, and have another round of points, say 3 meters higher.
Okay, that was my question. Do you have a recommendation for how many points around the perimeter, or how often?
Well, I will. One point is not enough. I will do, depending, of course, depending on the use of the. If it is a cutting wall or a plug, it changes a lot, no? So, for example, if you want to be extra sure that your columns will sort of, you won't have any gaps. So maybe you just need to take measures on a side, or maybe, it's up to the designer. It's up to you. In the test we did, we made 3 measurements. That's it. Then, it will take more than half an hour.
All right, thank you, Valerio.
Thank you.
He'll
Thank you.
stick around if you have some more questions. Sounds like a lot of interest.